about history of Malaysia.
What about what's happening in Elevator Road? Can you tell me what's the background?
Okay. I'm not certain. Elevator is the long name,
What's
which it would take a whole paragraph. So we take the partial conclusion. The full name is Guelam Prajas Anti-Mud Police Auditor.
Okay. That's a big name.
Sounds weird, right?
Sounds very weird.
The family had been prominent once in front of many generations going back to around 20th century.
And?
Then, as a child, Elepitel had no talent for subjects like the tea, but he developed strong mathematical abilities and real passion for the subjects. Bernard D. Fontenelle in 7 recounts that when Elepitel was 15 years old, he was on one occasion discussing mathematics with the Duke of Rhodes and Mr. Enna. They told him about a very difficult problem on the cycloid that Blaise Pascal had proposed. A few days later, Elepitel had solved the problem. If his family background, it is not surprising that Elepitel followed a military career, served as a captain in the cavalry.
So for example, sometimes we will face some problem that when limit x to 0, we sub 0 here, so we will get 0 over 0, then we can't get the answer. And sometimes also maybe infinity over infinity, so we can use L'Hopital rule to solve the problem. So for example, this question. So first, to use L'Hopital rule, we have to differentiate this and this. So these two parts we have to differentiate. So we will write like this. So sine 2x we differentiate will become 2 cos 2x and over 1. So that the final answer we get is 2. Okay, this is how we apply L'Hopital rule.
Is there any application in L'Hopital rules? Yes, I have one problem that can be solved with the proposed theorem, which is the application is continuous compounding interest rate. Okay, this is an example. This is given A for amount, R interest, and continuous compounding T years, P initial deposit. Okay, N is continuous compounding is refers to M. N equals to infinity. Value of A is limited when N approach to infinity. Okay, the first step we will use this formula and change. We will use the L'Hopital rules to make this formula. Okay, the first step is we will put the loan on both sides, this side and this side. After that, this power we will move to the front of the loan. This we will move to this and will be like this. And after that, the N we will move to the denominator. That will be the 1 over N. Okay.
Then the L'Hopital rule is applied after this. Applied in the numerator and the denominator. Then we differentiate numerator and denominator. We get this. Then we factorize R and N outside. Then substitute infinity. Then 1 over N squared and 1 over N squared we can cancel out. Then we substitute infinity to the N unknown N. Then it becomes 0. And then it gives equation like this. Then we move ln to the right side and get the exponents. Then lastly it will become like this. So that's the
Okay, then the list of application that use this concept, which is L'Hopital rule, continuous compounding rate, which I explained before, and the gamma function. While for the gamma function, the application is used to model the factorial function. That's all the application that have in L'Hopital rule.
That's all the application
That have applied
Yes.
for the concept of L'Hopital rules.
Alright, let's do a question about L'Hopital rule. Okay, this is a question that I want you to do. Firstly, we could factor the numerator and denominator, simplify and take the limit. However, that's going to be more work than just using L'Hopital rule. Okay, firstly, we need to differentiate the numerator and denominator. Okay, firstly, we need to differentiate it. Then we put the limit into the t. Then because the limit is 1, put the limit. And finally, we got the answer. That's all.